The monitor, the screen, is the primary output peripheral. Used to display data in text or graphics. Displays data in the form of characters consisting of pixels in text mode, directly in pixels in graphic mode. There are two different principal screens, CRT and LCD, which can be monochrome and color. In a cathode ray tube, CRT, monitor, an electron gun emits electron beams onto the light-emitting image-coated image surface of a cavity, attenuated, image tube, moving from the upper left corner to the right and down one row at a time. The electron gun monochrome monitor emits one electron beam at a time, which carries one color, while the color monitor emits 3 electron beams, RGB signal, each with a base color, red, green and blue. The electron beams pass through a mask using horizontal and vertical deflection coils. The holes in the mask determine the location, number, and size of the pixels, in dpi or millimeters. The more the number of holes, the higher the resolution, and the smaller the size of the holes, the smaller the pixels. The mask can be a hole mask, a metal plate with an inline or delta layout. Instead of sheet metal, Sony also uses a stretched wire mesh, a Trinitron mask. In the inline arrangement, the holes are located next to and below each other. The advantage is that it is relatively simple, the disadvantage is that the black parts between the pixels are visible, so stronger light must be applied. The most common, delta type, has holes in a triangular shape, so the parts between the pixels are less visible, less light has to be applied. Trinitron, which is used only with the color monitor type, does not have holes, but vertical bands, and each band has an electron beam, R, G, and B, so the color points are next to each other. The image is sharper and brighter, but the horizontal thread connecting the vertical threads in the third of the screen is visible. There are two modes, interlaced or interlaced, and non-interlaced or continuous. In the alternate series, the electron beam prints the odd number of lines in the first step and the odd number in the second step. In continuous mode, the image is displayed one after the other, resulting in less fine resolution, but more frequent image refresh. This results in higher resolution, but lower image refresh rate. In non-interlaced mode, it renders an image in less than 1/50th second. In interlaced mode it takes 1/2 image in the same amount of time, so a full image takes approx. in 1/25th second. The slim LCD, liquid crystal display, with a thickness of a few centimeters, works with liquid crystals. A liquid crystal is a gel-like substance made up of rod-shaped molecules. Two liquid crystal sheets are placed on top of each other so that the rods are perpendicular to each other, thus blocking the path of light. When an electrical voltage is applied between the two plates, the molecules are arranged in the direction of the voltage, i.e. the light passes through the pixels according to the magnitude of the voltage. Black and white and color versions are also available. It is much smaller in size and has much less power consumption and radiation than a CRT monitor, but is less bright. Laptops and notebooks are made with such a screen. Monitors can be classified according to other aspects. The OSD, on-screen display, monitor displays the settings, brightness, contrast, etc. on the screen. The digital setting monitor digitally stores various settings, egg screen surface size, position and shape, brightness, contrast, etc. It is not set with potentiometers, variable resistors, so it can even be controlled by software. The multi-sync, also known as auto-scan, multi-scan screen can change the resolution without jumping to the image, in which case it automatically adjusts the horizontal and vertical synchronization in an instant. The overscan monitor uses the entire screen area, so there is no narrow black frame at the edge of the screen. All monitors have harmful radiation. The picture tube attracts air particles and human cells and then repels it after it is charged. Various monitor filters in front of the screen can prevent harmful radiation to some extent, but it is more appropriate if the monitor is already more environmentally friendly. The low radiation monitor emits less harmful radiation. Three common standards are used: MPR, MPR2 and TCO. The power-saving monitor is capable of power-saving operation, which means that if you do not work with the computer, the screen consumes less power after a specified period of time. The most common energy-saving standards are the VESA, Video Electronics Standard Association, Consortium DPMS, Display Power Management Signaling, and the Swedish company Nutec, as well as Energy Star, which are not only for monitors but also for others. The resolution shows how many pixels the screen consists of horizontally and vertically. In text mode, the resolution is not specified per pixel, but per character. A better quality monitor has a minimum resolution of 1280 x 1024 pixels. Color depth determines how many colors and hues the screen can display at one time, how many bits of a color it displays. For a monochrome monitor, this value shows shades between black and white. Newer monitors are capable of displaying 24-bit color depth images. Pixel size shows the size of a pixel in millimeters and the number of pixels per inch of the screen in dpi. The smaller the pixel size, the finer the grain. This value is usually around 0.31 mm for older monitors and 0.25 mm for newer monitors. The diameter shows the diameter of the screen in inches, German in Kohl, English in inch. 1 inch approx. 2.54 centimeters. The larger the diameter, the larger the image, the better the image detail. The most common sizes are 14-inch, 15-inch, 17-inch, 19-inch, 21-inch. Frame rate or frame rate is the value of vertical sync in hertz. This value is provided by the monitor manufacturers, but we can calculate it ourselves as follows. Line frequency vertical resolution. The higher the frame rate of a monitor, the denser it displays images. The line frequency shows the horizontal synchronization in hertz. Calculation. Vertical resolution, number of lines, times frame rate. For example, a monitor with a resolution of 1024 x 768 and a frame rate of 75 Hz has a line frequency of 768 x 75 Hz equals 57.6 kHz. The pixel frequency or bandwidth gives the speed, i.e. the frequency, of the scanning electron beam expressed in Hz in the horizontal direction. Calculation. Line frequency times horizontal resolution plus 10% or resolution times frame rate plus 10% must be increased by approx. 10% due to line feedback. Projectors can be used to project large images on a smooth surface, wall or canvas. Their structure is very similar to that of monitors, but they use much stronger light due to projection over greater distances. They have two types, CRT and LCD. A CRT projector, like a monitor, uses an image tube to produce the image. The resulting image is illuminated with a high-intensity bulb so that it is visible on the wall at the appropriate brightness. The LCD projector also uses liquid crystal displays. Behind the panels, a high-intensity light bulb illuminates to project. In both types, the bulb is cooled by a fan. With the help of mirrors and lenses, we can focus and enlarge the image so we can project from a distance of several meters. You can also connect a monitor to the projector. The monitor or projector must be connected to the computer through a video card or monitor that is appropriate for the type of monitor or projector. The video card determines how well the computer can take advantage of the monitor's resolution, color depth, and maximum horizontal and vertical synchronization. The structure of the cathode ray tube. Path of the electron rays from electron gun to light emitter layer. Location of holes in different masks. The inline, the delta and the trinitron. The non-interlaced and interlaced mode.